Screen is visible.
Yes, ma'am.
Om Kumar Tiwari.
Yes, ma'am. Hello.
Yes. So we
Yes,
were
ma'am.
discussing about abstract data types. The various abstract data types available in most of the programming languages are stack is a last in first out. Can anybody give best example for stack where we are using stacks in real life? Stack is like a container. So if you take the CD, olden days we used to use CD container. The CD container will have a stick, and we'll put all the CDs in the stick. The same way, if you go to the hotel, you can find an normal hotels. You can find an stick kind of holder. They will put all the bills in the particular stick. So if you want to take the first item, access the first one, you have to remove the before in a stack. If there are 5 items, the previous four, if you want to access the first one, and totally it's having 5. You have to remove the 4 elements, then only you can access the fifth element. Or you can take the tiffin box. The carrier may be containing 3 or 4 boxes. So if you want to take the first box from the carrier, the previous 3 boxes should be removed. So the same way, last in first out principle is followed in stack. What are all the operations we can perform using stack? Means push means add items into the stack. Pop means remove the elements from the stack. Peek means return the item at the top of the stack without removing it. And is empty is on condition. We will check whether the stack is empty or it's having elements. The keywords, stack is a keyword in most of the programming languages, and the keyword push, pop, peek, is empty, they are also keywords. These words we should not use for our functions because they are all keywords. And if you take a queue is a first in first out data structure. We are most common queue is in airports. In railway station we are not following queue. In buses also we are not following any queue. Only in airports, no other way, they are standing in queue. So the person who go on stands first, based on the zonal, they will make an announcement. They will say zone 1, zone 2, something. So they will call only the zone 1 people. Then you have to go and stand in the queue. Within that particular zone, those who went first, their check-in will be made first. So first in, first out. The person who comes first will be served first. And in the queue, we have the operations or functions associated with queue called NQ with parameter. Because they are all function, followed by the name, we have the opening and closing bracket. Here pop also, because we are going to remove the element from the stack, no argument. Return type also, return type will be there, but no arguments. Even though there is no argument, the function name followed by opening and closing bracket. It means that it is a function. Function means it is an operation. This operation is associated with a particular class. The same way in queue, we have the following functions. NQ adds an item to the rear of the queue. So the word rear is associated with the variable is associated with the queue. We cannot use the word rear along with stack, or we cannot use the word rear along with the graph. The terms used in a particular abstract data type is associated with the particular data type alone. The same way pop we cannot use with queue, or we cannot use the pop with the tree. because the function is a keyword, it is associated only with the stack only. And if you take a DQ function, it removes and returns an item at the front of the queue. Removal happens always from the front side. In queue, we have we have one entry, one exit. Front is the exit, rear is the entry point, like airport, arrival and departure. We will start in queue. Through front, we will delete the element, and through rear, we will add the elements. Front and rear are the keywords, variables associated with the queue. And we have one function also, front function. The function returns item at the front of the queue without removing it. And we have a function called rear. And here the front and rear are variable, and we are giving the same name to the function also. If you take the same name as class name, then it become constructor. But the variable name front and rear is used for the functions also. Is empty, check the queue is empty or not. If the queue is empty, we cannot perform any operation. The queue is empty, we cannot delete. In the same way, we have the abstract data type called tree. The tree means it is a hierarchical data structure, level 1, level 2, level 3, like that. And the elements in the first level or the 0th level will be root node. As in general, every tree is having the root. Without the root, the tree cannot stand. The same way, there is a root for the tree structure. From the tree only, from the root node only, we will get the branches. And the root node is always one. Every tree will have only one root. And if you want to add elements into the tree, we will use the function insert an item. Delete, if you want to remove one cut and branch, then you can, or cut an item, delete the item. Traversal means the tree will be having a number of left subtree, right subtree, or a number of branches. If you want to visit each and every, if you want to visit each and every tree, or if you want to pick the flower, pick the fruits from the tree, we will traversal. We will go to each and every branch. So that is called tree traversal, or we will visit each and every node in the tree. So through the tree traversal only we are getting notations like prefix notation, pre-order traversal, post-order traversal, in-order traversal, and find from in a tree structure if the elements are stored, whether the element is found in the tree or not. Searching for an element in the tree is possible. If you take the graph structure, graph is an abstract data type. With the graph structure is a collection of vertices and edges. A tree is a root node and nodes and multiple children's. And graph is, in graph we will use the words uh, vertices. Vertices means the nodes, and edges means the graph, various graph notations are connected with each other through the edges. In graph, we can add vertex and add an edge. We can put two nodes and we can connect both the nodes through one edge. The edge distance represents how long, say we have two cities, Bhopal and Indore. Bhopal is a node and Indore is another node or vertex. The distance between one node to another node through the edges we can measure. We can connect both the cities through an edge. The distance between those two cities can be represented a weight on the edge, and add edge into the. We can add an edge in between two vertices. We can remove one vertex from the graph and remove an edge from in between any two vertices. Find and vertex, whether and vertex is available in the graph or not. So these operations we can perform with the graph. In graph, how will traversal means through the single source shortest path, or breadth first search, depth first search, or visiting all the nodes in the graph, like a traveling salesman problem, shortest route problem method, or there are some special algorithms available like Prime's algorithm, Kruskal's algorithm. They will provide you some logic or technique so that we can minimize the traveling distance. Say for example, a postman in olden days, a postman will be there. Nowadays, we are having the delivery, Amazon or Flipkart delivery. Na? So they want to deliver the product to all the customers door delivery within the city. Some 10 people may order the product. So they have to calculate. They have to visit each city or the edge only once. They visiting all the nodes only once through one shortest path. If you take hash table is an abstract data type. The various functions associated with the abstract data type are inserting an key value. In hash tables, we are using, can you give some example for hash tables? Then all the abstract data types are implementation of real-time scenario. Whatever we are using, whatever we are doing, some optimization techniques we are following in real life, traveling, uh, performing, using, doing, standing in queue, using and stack. They are all real-time logic. The same thing they converted into abstract data types. Can you give some example for hash table where it can be used in the real-time scenario? I think in most of the social media they are using a number of tagging, hash hashing techniques. We are using the simple hash. Before any keyword, if you put hash, that will be highlighted. Instagram, Facebook, Twitter, or LinkedIn, or YouTube. Keywords, hashtagging. What is the logic behind that? If you click the hashtag, it will bring you all the interrelated concepts with the same topic. And we are getting in social media, what is that? India trending, world trending, how the trending thing is retrieved. So the same logic is used in the hash tables. So here we are using the key, the search key will be used, and the value associated with the key will be mentioned. Say we will create a table. The table, you know very well, it's in rows and columns. In that case, it will have the in the table will have some serial number followed by the value, and the value how it is associated, where and all it is referred. Say if you take the book, the textbook, end of the book, you can find the index. If you go to the index, you can find, if you take data structures and algorithms book, if you see the keyword queue, where and all the queue is referred, definition of queue, implementing linked list using queue, creating DQ using queue. So the topics may be referred in different chapters. In introduction part, queue definition may be given. So if you see the index queue, the index will be mentioned in alphabetical order. Or if you take the keyword algorithm, you can see the keyword algorithm followed by so many brackets. Algorithm page number 2, algorithm 25, page number 25, algorithm, Kruskal algorithm page number 500, shortest path algorithm page number 350. Like that, where and all the keyword algorithm is mentioned or the subheading algorithm is used, you can find all the page numbers indexing. The same way in hash table also we'll have the key and the value associated with the key. So adds key value pair to the hash table. Key value pair storage is represented using hash table. So through the hash table, you can easily access where and all the concept is stored. And delete, we can delete the key, and find, we can find the key. Through the key only we are accessing the data. Say in google.com also, Google search also, if you mention the keyword, it will list out hundreds of pages where and all the algorithm. If you type in the Google search, it will show a number of websites where the algorithm is used. Algorithms using C, algorithms using C++, deep learning algorithms, convolution neural networks algorithms, AI algorithms, machine learning algorithms. So like that, it will list a number of pages having the keyword algorithm. So the hash table is used to access the key value pair. The same key value pair is used in the object-oriented databases also, where they will store the object-oriented data. In normal DBMS and RDBMS, we will use only the basic data types. or user-defined data types. Integers, characters, float, and double, or those data can be stored in a table form. Normalization can be done. The normal DBMS, SQL, MySQL will process a normal DBMS or DBMS tables. But if you want to store uh, the multimedia data, the data in the form of image, the data in the form of pictures, the data with video clips, emojis, and other audio recordings, video recordings. Those data cannot be stored in normal DBMS table or RDBMS table. For that purpose, we need object-oriented databases like MongoDB, CrunchDB, Neo4j, and Cassandra, or the key value pair document-based databases are white column databases. There, in white column databases, they will use key value pair. The key will be there, and the value may be image, or it may be audio signal, or it may be a live stream video, where they will store BLB, large value data will be stored. So any doubt with these various abstract data types? So abstract data type means data along with the function. Example for data along with the function is stack, queue, tree, graph, hash tables. These every abstract data type is having its own functions. The functions are specially created for the particular abstract data type. It's having its own meaning and operations. And through the built-in functions, the internal operations, because they are all almost built-in functions or library functions, we can include those things in our programming, C or C++ or Python, through the header file. We can include hash include stack.h, hash include q.h, or string.h. You include, we can make use of all the built-in functions. The functions already predefined and available in the corresponding standard template library as well as in the abstract data type. And almost all the data types, abstract data types, are common for all the programming languages. So any doubt in this? What is ADT and examples? Any doubt? Mega, Rajiv, Sanget, Sanget Magabhadra. Any doubt?
Um,
They given some additional explanation, abstract data types and implementation. Consider the example stack. If you require stack with the predefined limit, fixed size or varying size stack, we have a fixed size arrays and varying size array, or we can create dynamic, we can use dynamic memory allocation also during runtime. An array based implementation is your go-to. Arrays are superb when you use maximum number of items the stack will hold, offering fast access and straightforward usage. When you study the subject called compiler design, there also you will use the, when you evaluate a simple expression, C equal to A plus B, or if you are evaluating a complex expression, multi-mode operations, x square plus y square divided by 2 multiplied by z. In that case, in the mixed mode operations, what we will be using the stack. The operands will be, it will read the expression from left to right. It will take the first operand, put it into the stack, and read the next operand, put it into the stack. Then it will retrieve the operator, apply the operator on. It will pop the both the operands. Operands means variables. Apply the operator on the operands, and it will evaluate, store the result into the stack. Again, it will read the next two operands, apply the operator. So like that, it will evaluate. So we'll be using we'll be using the table hash table, as well as we'll be using the push and pop, and the same pre-order traversal, prefix expression or postfix expression. If the expression is in infix form, say c equal to x square plus y square plus z square, the expression will be expanded. Then it will convert the expressions prefix form. So if it is in prefix form, x plus y will be represented as plus xy. In that case, the first two operands will be extracted and it will be put into the stack. Then it will take the pop the operand and apply the operator. Again, it will push into the stack. So it will evaluate. Internally, the compiler will evaluate your expressions using hash tables, and it will use the pre-order traversal or post-order traversal, as well as it will use stacks. So the compiler is designed in that way. The compiler is using all the stack, queue, tree structure, all those things for various internal mathematical CPU related arithmetic and logical operations. Inside the computer, we have CPU. Within CPU, we have ALU. In the ALU, we are performing arithmetic and logical operations. Each and every logical operation is performed differently. So in that case, if you the same way when you create the compiler for C compiler or C++ compiler, there we will be using these abstract data types, queues, stacks, everything will be used. That logic is used. Even if you create the printer device driver, the printers are maintaining the printer queue. So you are giving 5 files print out. The first when the first file is printing, the remaining 4 files will be in the print queue. You can clear the print queue, or you can check what is pending in the print queue. So the queue logic is implemented in the printers. If you require a stack with or without array, any fixed size array, limit or dynamic stack, then a linked list is based implementation is used. So if you want to create and stack dynamically, your stack size is not fixed, and if you want to add the elements during runtime, and your stack size is varying size array, in that case, a new object will be created, and the elements will be pushed into the stack. If you, it allows your stack to grow and shrink without the constraints of fixed size. Your stack may be a fixed size, a static stack, or it may be a dynamic stack. The elements can be added based on the need, dynamically allocating the memory space. See the image below that help to understand the abstract data type and its operations of stack. If you take this stack, it can be created by using array, fixed size array, or linked list. If you want to allocate my memory dynamically, the queue can also, while creating queue also, because it is we need to allocate, we have to declare the variables, we have to assign memory space, and the functions need to be declared and defined, and the operations should be interlinked, and how this queue can be created. But a abstract data type provides you all the stack and stack operations, all the data types and its operations. But if you don't want to use the built-in functions from the STL, and you want to create your own queue as a programmer, you can create the queue using arrays also, or you can create the queue with the linked list also. You can create the queue using circular buffer also. Buffer means memory space, using temporary memory space also. And if you want to create the hash table or map hash table and map is also here. Hash table is key value pair. The same way map data structure also related with the what is that position of the map is accessed through the what is that we have the two values now. What are the two values associated with the map? Say if you are pointing Gopal, it's having
coordinates.
latitude and longitude. So through the latitude and longitude of all the places is different. So in map also we are using key value pair, latitude and longitude. In a hash table also the key associated with the value and key. And that hash table can also be created by using array of buckets. That is creating a single dimensional array with memory spaces. or the same hash table or map can be created by using linked list. How we can create using linked list means the map is having the current positions value, and it will have the linked list means the value and the index value or the address of the next element. If it is doubly linked list, address of the previous element and value and the address of the next element. So if you take Gopal, the previous stopping and the next stopping, next major city or next place. In graph structure, the graph structure can be created as a programmer, because why they are giving all those things means in our data structures and algorithm language, we are not going to make use of the built-in functions. You people are going to write all the functions. So they are all the data structures we are going to study. As we discussed, they are available in all the programming languages. The abstract data types are available in C, C++, and all the built-in functions also available in the standard template library. While writing your own stack programs, the pop function, each and every line you have to write. How the push is performed as a data structure and algorithm programmer, you have to write each and your own lines should be written. You can take the logic, you can refer the pseudocode. The lines of code should be written in C or C++ for push. You are not going to use s dot push dot 5, 10, not like that. You have to write the code for push pop. The same way when you are talking about Q, DQ, all those things, you have to write your own line by line coding for NQ, DQ, front, rear, is empty. The same way while talking about graph, you are going to write adding values, adding vertices, removing the edges, using Kruskal's algorithm or Prime's algorithm or shortest path technique, whatever may be the logic you are going to use. All the functions you are going to write. You are not going to use any built-in function. Even though it is available, you have to write and understand. While writing with the graph structure, while creating the graph and writing the corresponding adding and removing edges, adding and removing vertices, checking the graph is empty or not, or performing a graph traversal, breadth first search or depth first search. The graph can be created using adjacency matrix, as well as the graph can be created using adjacency matrix also. So graph means we know we'll have a number of nodes. Say Bhopal is one node and Indore is another node. Asta and Asta is another node. What is that? Shihor is another node. So how we will represent all those nodes internally in the memory means, so we will connect all the nodes together and the distance between all the nodes will be mentioned on the edges. And if there is a direct broad connectivity between, say, Mark, Bhopal, Indore, Asta and Shigor as 1, 2, 3, 4. So we'll take a two-dimensional matrix with x comma y. We have 4 cities. In x-axis, we'll have a 1, 2, 3, 4, and y-axis will have 1, 2, 3, 4. We'll create a table. If there is a connectivity between 1 to 1, then you will put mention 1. From 1 comma 2, you will have the point in the matrix 1 comma 2, 1 comma 3, 1 comma 4. So if there is a path or connectivity, if they are connected, then we will put 1, 1, 1. If there is no direct connectivity, we will put 0. So that we will get an adjacency matrix. In that way only it is represented. If there is an edge between one city to another city, the graph or the table will contain 1. If there is no edge between any two cities, there is no path between any two cities, then we will mark 0. Then we will process the adjacency matrix. Then we will perform all the shortest path, choosing the right path. The same way, while creating the tree, you can create the tree by using linked nodes concept only. The same way, while create the linked list, it can be created by using array of continuous memory, or the same linked list can be created by using node points for non-continuous memory also. The heap structure can be created by using array, commonly for binary heap, and a set can be created by using hashing table or binary search tree concept. The same way we have the dictionary concept that can be created by using hash table and binary search tree. Dictionary means we know very well, all the keywords will be there. and the meaning associated or the explanation associated with the keyword will be there. So that can be created. So any doubt with the concepts, what we discussed? For example, an ADT for a stack specifies operations like push and pop and peek, but does not specify how it is actually implemented. So same ADT can have multiple implementations. So within the same abstract data type, it can the logic can be represented differently. Say the same stack with push operation. The push operation, each programmer can write in different way. Different sentences can be used, but the logic is same. For example, the stack ADT can be implemented using an array or using linked list. The sentences, they may use for loop, or they may use while loop or do while loop, or they may use go to statement or any other. The addition can be performed. Say the multiplication can be performed as multiplication, or we can do it as a successive addition, like that under linked list, but the abstract behavior, push pop top operations remains constant. The logic should be followed, and it can be created using array also, or it can be used linked list also. You may use recursive function or without function, or only main program, or may use classes and objects. Logic, the sentence, the programming lines can be anyway, but the logic should be there. So any doubt with respect to abstract data types? How many of you completed the
Yeah.
programs?
Complete.
Any doubt with respect to abstract data type? Have you gone through the PPT I have uploaded?
Yes.
And how is a dictionary different from a hash table?
Have you? Have you completed the programs? Lab program? Any doubt? Abhishek Anand, you said something.
No doubts. I guess someone else said something.
Okay, with this, we are coming to an end of the first unit. We discussed, go through the syllabus also. We discussed algorithm introduction, algorithm design complexity, asymptotic notation, data structures, introduction, classification of data structure, and abstract data type. Along with that, we completed one lab program also. We already, as part of explanation part in the theory itself, we discussed what is linear search, how to write the observation for the lab component, name algorithm pseudocode, program flowchart, and sample input output. And how to maintain the observation, how to write the answers for all the 10 programs in hand. Then you have to scan and upload in the Google Classroom. You will be writing all the 12 programs in the observation only. So you go through the topics, whatever we uploaded. If you have any doubt, ask me in the next class. For your reference, some recordings of your class I have already uploaded. Go through that recordings also. During your class timing, especially 3 o'clock, many of the meetings are happening. So I think we skipped 1 or 2 classes also. I already shared with you the linear search using recursive and non-recursive functions. And the bubble sort also we discussed in the algorithm design concept. Game algorithm, pseudocode procedure, the program. Okay, go through the programs. If you have any doubt, based on the first week of lab assessment, you have to complete linear search and binary search. Any other doubt with respect to unit 1? If you have any doubt, ask me in the next class. Next class, we are going to start unit 2. And parallelly, you go through the lab programs also. Any doubt? Okay, go through the PPTs and go through the textbook also and refer the syllabus. Have any doubt? Ask me in the next class. And the meeting will end in another. End in another 2 minutes. So go through the syllabus list of programs given. So if you take the syllabus, the first exercise is, so you need to complete all the 12 programs that will come under lab assessment. Second program, we discussed implementation of searching algorithms. In general, we will use linear search or binary search only. Linear search and binary search, both I have given the PPT as well as this you need to complete for the last week and this week, 2 weeks. Anyhow, we have to discuss bubble sort, merge sort, quick sort the next class. Okay, I will end the meeting. It will end in another 1 minute. Any doubt, ask me in the next class. So the difference between hash table and dictionary means dictionary is, the Oxford dictionary. Hash table means key value pair searching. We are using hashtag like that.